copper chloride is available in excess?
You don't need to know that yet.
Okay. So then for number 4, we can just cross that out too. And
Yeah,
then,
it's an important disclaimer, but it's not. It's kind of an unnecessary piece of information for you
yeah.
at this point. Okay. Again, I would probably, I would just check kind of visually that it's balanced. It looks like it is. So that's a good start. You always go with whatever's given. 83.0 grams of AgNO3
NO3
times
1 mole of AgCl above.
This is AgNO3. You first convert it to moles.
And then here we're finding the molar mass of silver, of nitrogen, oxygen, and adding them together.
Yes. Yeah. AgNO3, which is probably like a silver nitrate. But you just have to get the molar mass of Ag times 1, nitrogen times 1, and 3 oxygens. So I've got that number here. If you don't mind calculating that, that's an important intermediate step.
Yeah. I got 169.877.
Yeah, maybe even just go 170. I don't know how if your teacher cares about that, but that now you're in moles. Now you're in really good situation here. So you're now going to use the coefficients of AgNO3, and you're going to AgCl. So you've got to show this, even though it doesn't really change anything. It's 1 mole AgNO3 on the bottom. That's got to match the top left. 1 mole AgCl up top.
And so our answer is just 1 mole of AgCl.
Well, the answer is in moles of AgCl. You have to still do the calculation.
Oh, right. So, 83 moles of.
It's 83 grams. It's grams. Cancel the grams. Moles cancel the moles. Your answer is in moles AgCl.
Oh man, I don't think I did this right. I got like 0.48.
Yeah, that's correct.
Oh, it is? Okay.
Yeah. Whenever you multiply by 1, it doesn't do much. It doesn't do anything really. And then you're dividing by the number on the bottom.
I think I got number 3 wrong then. I think
This was 0.35 moles of zinc Cl2.
Okay. Okay. So number 4, how many moles of water will be produced from 26 grams of H2O2?
Let me know when we can move on to the next one.
Yeah, so I was for number 5. How many moles of H2O will be produced from 26 grams of H2O2?
Okay. So which number, what are you going to start with? What are you going to write top left or first?
26 grams of H2O2
Good.
times
So,
1
yeah, what are you going to do
mole
here?
times 1 mole of water H2O
Nope, nope,
over
nope, nope, can't do that. You've not converted this to moles yet.
uh
So it's 1 mole
oh
H2O2
H2O2.
grams in H2O2.
Okay. So 34 grams H2O2.
Yes. And then this time though, we've got to now do the mole conversion from the coefficients here. So we're
2 and
going,
2.
yeah, it's 2 and 2 again. I mean, it doesn't always work out. They're the same, but it does in this problem.
So we can cross out those coefficients, right?
Yes.
Equals 0.81.
You're doing 26 divided by 34.
No.
Because you like you said the twos cancel.
Yeah. I left the twos out. What I did was I did 26 times 1 divided by 34.
Yeah, that should be 0.76, we'll say.
Yeah, I got that now, but I
Okay.
think it's just the way I put it in my calculator. And then some number 6 now.
All right. So this is the new style of question. See if it's
Mhm.
see what we got. Let me grab a snip here. All right, how many grams of C2H6 are required to react with 12 moles of O2? So what are you going to start with in the top left?
12 moles of O2.
12 moles of O2. Now, because you're already in moles, you don't have to do that molar mass conversion.
Oh, so it's like we're starting at the second step.
Yes, that's exactly right. So,
Above.
but you're going from 7 moles of O2 and you got to use the coefficient for the C2H6, 2 C
How did you get the
moles.
7 moles of O2?
It's given in the problem. It's the coefficient.
Oh, okay.
It's this number here and this number here.
O2. Times 2 or 1 mole.
So are you up to this step here? Because the next one's new. This is new.
Oh, okay.
Okay, because now it's asking for grams. You have
Yeah.
to convert from 1 mole C2H6 is
Mhm.
grams of C2H6, and that's where you have to go to your periodic table and get the molar mass of C2H6.
So 30 grams of
30 grams, good.
C2H6. And now we just do the math.
Yes. This one's got a bit more to it. The other ones have been kind of nice, but let's go to 1 decimal place on this one.
Okay. $102.9.
Okay, and make sure you have your units, your grams of C2H6.
Grams of C2H6. Okay.
All right, next page. Turn the page over. So part B.
Grams of O2 are required to react with 200 grams of C2H6.
Okay, sorry, I was looking at something else because it didn't get the right page. Here we go. Got it here. B. How many grams of O2 are required to react with 200 grams, like you said, of C2H6? So start with the 200 grams C2H6. Whenever you're given grams, you immediately go to moles.
Oh, okay. And then vice versa.
Depends on the problem. But moles are the only way you can convert in these equations. So we need the molar mass of C2H6, which we have from the previous problem, is 1 mole of C2H6.
Times.
So from here, this is where you go back and use the
Oh,
coefficients.
the coefficients. That's right.
Yes, C2H6 is here. There's 2 of them. We want to go to O2. So there's 2 moles C2H6.
7 C2 or O2.
Okay, so we would be done at this step if we were asked for how many moles of O2 are required, but we want grams. So there's an additional step here.
H6.
So 1 mole O2, we need the grams of O2 from the molar mass.
O2. Grams of O2. 7 moles of O2 to grams of O2. 1 second. Times. Is it 224?
You just O2 grams of O2. So it's just 2 O's. 32 grams.
Oh.
So like whatever,
Okay,
like
yeah.
whatever it is, you don't worry about the coefficients.
Yeah. I tried. Okay. 32. So now 746.6. Grams of O2.
Yes, 700, maybe we'll go 47 grams of O2, like that. Good. This was kind of the full problem,
Uh-huh.
most
Okay, so
you'd say.
we started with 200 grams.
Yep.
And then we did the grams to mole conversion,
Molar mass, yep.
or the molar mass. And then we just put the coefficients.
That's right.
How did we know to use? I mean, I guess they're the only two things in the problem, but for example, for number 6, or no, sorry, I don't mean to confuse you.
Which problem? 6.
No, sorry. 6B.
Mhm.
How do we know which one goes on top and which one goes on bottom? Like how do we know that O2 goes on top and CH6 goes on the bottom?
So it really starts from the left. Do you see that C2H6 top, C2H6 bottom?
Mm-hmm.
And then it went on top again because you were converting to moles. So see how it was on the bottom?
Mm-hmm.
Like it had to go on the bottom. So that means the O2 has to go on top.
Oh, right, because it's going diagonally.
Yeah. Now, if you really focus on the way I've been doing it, you'll notice most of the time I write the one on the bottom first and then go to the top because the bottom one's got to match the one on the left, top left.
Oh, okay. And then from there, we got one. Well, I mean, 1 mole of O2 always goes in that part, right?
Yeah, on the right here. Yes.
That's always like that. And then the 32 grams of O2 is just kind of.
From the periodic table.
Mm-hmm. And we just multiply it all together. Okay. So for number 7, how many grams of KCiO3 are required to react with 62 moles of KCi? So in top left, we're writing 62
Yes.
moles KCi.
L, that's an L, KCl.
Oh, KCl.
Yeah, it's chlorine, Cl. So what goes on the bottom? This is the question you asked me, but what goes on the bottom down here?
62 mole.
Mole, just
KCl.
mole KCl.
Okay,
Mole
mole.
KCl. Okay.
And then on top, gram KCl.
But we're already in moles. We're already in
Oh,
moles. So we want to go from moles to moles of something else, the thing we're trying to get to. So moles KCl to
moles of KClO3.
yes. Now, where do we get those numbers from that go in front of this?
Oh, we're on the second step, so this is like the coefficients,
Yes.
which is just 1 and 1.
2 and 2. 2 and 2.
Oh, right.
Now, what goes on the bottom right is what was on the top left.
So on the bottom right is now 2 or mole KC.
LO3. Yeah. And we want to go to grams of KClO3. So that's where we go grams KClO3.
Oh, and then it's always going to be 1 mole in this bottom right corner. Okay, and then with this one, we just use the periodic table. So potassium Right. Plus chlorine plus so 122.54
Yeah,
or 123.
sure. 123 is good. You don't have to be that close. Yep, very good.
And then now we just 7,626 grams of KClO3.
Very good.
7626. Okay, and so this one we knew the moles already because they gave it to us in the problem. So we started with moles,
That's right.
and that's why we were kind of like on the second step already. When they give us grams instead of moles, that's when we have to
Have to do the first step, which we'll
and
see
so
in the
that
next. Go ahead.
so that first step of when they only give us grams of converting grams to molar mass, is that 1 mole always going to be in the top left?
I think you're asking about like what we did here.
Yeah, like for B, like
Yeah,
that 1
yeah.
mole of C2H6, that's
Yes,
always going to be 1 mole, right?
that's right. That's right. Yes, that's right.
Okay. And then that 30 grams of I mean, we just got that from
From
the
the
periodic table.
yes,
Oh, okay. Gotcha. So 1 mole C2H6 above 30 grams of C2H6 is giving us like that's getting us to where we're in moles.
that's right. Yes,
Okay. So sorry. Because that's like like an equation, right? It's like a number. We have
it's
like a certain.
it's always one, like you said, and I mean I wouldn't try to overthink it. It's the mole is like a representation of a large quantity of something.
Mhm.
It's no more significant than that. Like don't try to
Uh-huh. Okay.
overthink it because it's just a quantity. It's a collection of something.
Oh, and that one over 30 gave us the 2 on the bottom.
That came from the
Oh, the
coefficients.
coefficients, that's right.
Yeah.
Hmm. Okay,
I
let's
think
just
you're close to fully getting it. I mean, it's
yeah,
just keep going here. Get a few more of these in.
oh, for sure. So how many grams of O2 are required to react with 39 grams of or KCl? So we're in grams right now, so we have to do that 1 mole over the number we got from the periodic table.
That's right.
39 grams of KCl. 1 mole. And it's 1 mole of KCl, right?
It's
Yeah.
always 1 mole. Yes.
Of the number that of the molecule that we're trying to get.
Yes.
Okay. KCl. 75 grams of KCl.
Okay, good.
And then in the bottom right, it's going to be mole KCl. And it's 2.
It is 2. It is 2. It's good.
And then the 2 on top again of,
This
or
time
no,
though,
the 3.
yes,
of
3
2.
moles of O2. Yeah. Now, if it asked for moles of O2, you would be done.
And we would just multiply it like that.
Well, but we need grams. Yeah, we need grams of O2.
Mhm.
So we've got to keep going. That's where you're asking, like, well, does it always go 1 mole O2 on the bottom? Yeah.
Okay.
Grams of O2 goes on the
But
top.
if it was asking for moles of O2, we would still multiply the whole equation, right? It wouldn't just be like 3 moles of
If
O2.
if it asked for moles of O2, you would stop with what's in the box. You just do what's in the box. But because it asked for grams, you have to keep going.
Oh, okay. Hmm. O2. Under 32 grams. O2. So 25. 25 grams of KCl.
Nope, not KCl.
Of O2.
O2. Yes. Yes.
Okay. And then number 8 is kind of the same thing.
Yep. They're all very similar.
How many grams of CO2 would be required to react with 7.8 moles of water? 7.8 moles. It's too low. Times 1 mole of H2O on top, and then on the bottom, 18 grams of H2O.
So 1 mole H2O, because it's already in moles, you actually go right to the coefficients
Oh,
because it's already in moles. You need moles of CO2 here because it's already in moles.
CO2. Times 1 mole CO2 on the bottom. And on top, grams of CO2. So 44 grams of CO2. 7.8 times 16 divided by 8 times 44. So 686.4 grams of CO2.
Check your calculation one more time. Do you have these numbers here? 44 grams of CO2.
Yeah. I did 7.8 times 16 divided by, oh, I did 16.
6, yeah, not 16.
Okay, so 257 grams of CO2.
Yes, 257. Perfect. All right.
Nice. And then for B, how many grams of C3H7OH are needed to produce 0.45 moles of water? So we have the moles already. So we'd go straight to the coefficients.
That's right.
0.45 moles to so 8 mole H2O on the bottom, and then 2 C3H7OH on the top.
Sounds good.
OH on top times 1 mole C3H7OH on the bottom. Yep. And then on the top. Oh. Just calculating. So 10.1.
Try again. Try again. Get a calculation. You got 2 moles up top, 8 on the bottom. All right, 2 and 8, 60 and 1.
2. I put 3 instead of 2. Divided by 8. 60 divided by 6.75
Yes.
grams of C3H7OH. So how many grams of C3H7OH are required to react with 29 grams of CO2? So we have grams. So we need to do the mole conversion.
Good. That's right.
So I got after I did the 1 mole CO2 above the 44 grams of CO2
Yes.
multiplied by 2 moles C3H7OH
Good.
above 6 moles CO2.
Good.
Oh,
You're almost there. You just got to do that final molar mass conversion.
1 mole C3H2 above grams of C3H2OH. $55 grams of C3H7OH.
I've got a slightly different number there. 60 grams. I think we'd add that in the last one. Yeah, 60.
Yeah. Let me try that again. 36. Oh, I see why. Yeah, 60.
Okay, go ahead and calculate that, please.
So 13 grams of
Yes.
C3H7OH.
Got it. Very good.
Nice. So then 2 CH4 plus 2O2 to CO2. Okay, so we're in moles. So 97 mole CO2 times 1 mole CO2 under
So these are the coefficients
1 mole
because you're already in moles.
CH4. 1 mole of CH4, right?
That's right.
Okay, yeah. So then 1 mole CH4 under grams of CH4. 16 grams of CH4. 97. Uh, 1,552 grams of CH4.
Yes, that sounds right. It's sometimes the answers don't make any sense. I mean, what does even that mean? But
CH4. Okay. So how many grams of water is produced and 84 grams of CO2 is also produced. What? How many grams of H2O is produced? 84 grams of CO2 is also. So we're kind of working backwards on 2B, right?
I mean, a little bit. I mean, you try to overthink it. You just start with the given quantity, right? 84 grams
Oh, okay.
CO2. And since it's in grams, you know you're going to convert it to moles. But yes, to answer your question, yes, you are.
CO2.
But you need grams of CO2 and 1 mole of CO2.
So 1/16.
Where did you get the 16 from? It's CO2.
Oh.
CO2 is, yeah, 44. That's written really poorly, but
1/44.
good. And then you need
Times 1 mole of CO2 under 2 moles of H2O.
good.
Times 1 mole of H2O under grams of H2O.
Good.
18 grams of H2O. And then just plug that in. Sixty-nine.
Yep.
69 grams of H2O.
All right, really good. Did we get, looks like we got through
Nice.
everything with
Yeah,
1
we
minute
did.
to spare. I hope you understand this better. I mean, it seems like you were basically working at the last
Yeah.
few without much of my help. So
Definitely.
all right, we're going to go ahead and stop right here.